welcome to numerical ship and offshore hydrodynamics. So, today we are going to demonstrate a code which is written in C sharp, and also we have a code also is written in MATLAB. We discuss, if time permit, discuss both. Otherwise, today we are going to demonstrate with respect to the C sharp code, because it is much more structured way it is written. Okay. So, this is the keyword that we are going to use to get this lecture. So, let us discuss this. Now, as I discussed last class, that there will be something called the primitive class. Now, in primitive class, what we are going to do is, in primitive class we normally write some part of the structure or some part of the code which is very basic. For example, if I try to multiply 2 points, then that function may be written in the primitive class. Maybe suppose you want to make some array from the, let us say, bigger number to smaller number or smaller number to bigger number. So, these are very primitive type of functions or subroutines or that normally people use for many cases. Okay. So, or maybe let us say the find out the length between the distance between 2 points, that is again a function that belongs to the primitive class, because distance between 2 points can be used in finding out many things, right. Or maybe the area of a quadrilateral, that also may be the part of a primitive classes. So, these are the functions that we are going to write in the primitive class. Okay. The functions which can be used in general in many ways, not necessarily particularly solving this problem. Okay. So, let us see how we actually structured the primitive classes. Now, to solve this radiation problem in infinite domain, I use one primitive class which is called the points. Now, you understand that points is a very general thing. Now, a geometry is nothing but the collection of points. So, I must have a class which is deals with the points. Now, what is there? Vector. Now, vector also you understand, it is again very basic thing that you need, because let us say try to find out the area of a quadrilateral panel. We discussed that you define a vector between x 1 and x 2 2 points, and again you define a vector between x 1 and x 3 2 points, and then you do the cross product, and then you make it half of the cross product. Again you take 2 vector along x 1 and x 2 and x 1 and x 3, right, and then again you can make the same thing, and then you add this to triangular area, you will get the area of a quadrilateral. So, I know that for that you need the vector notation. So, also if you try to find out the normal vector, so therefore, you need definitely a vector. Okay. Third one is it is the panel, which is not that primitive class, but for attacking this particular problem definitely this panel class or the meshing, we can call mesh also in CFD, classical CFD or Ransbane solution, we are using it, mesh, structured, unstructured. So, this you can say the panel is nothing but a mesh. So, why it is required? Because you know that if you want to solve this problem using the panels, right. So, therefore, you have to have a class name called panel, right. And finally, the another basic class that I write here is the matrix. Definitely, you are going to use the matrix. Why? Because if you remember that finally, you are having a algebraic equation A x equal to b, right. So, then in order to solve this equation, you must have some matrix operation is required. So, therefore, you need a class, right, which is to help out to do this A inverse, to multiplication between two matrix, addition of two matrix, subtraction of two matrix, all this operation you need to store somewhere, you need to write somewhere. So, that is why we have this matrix class. Okay. So, these are the basic primitive class that I use to solve this particular problem. Okay. Next, what is the members of the primitive class we need to understand. Now, if you look at the point, so point is the x coordinate, y coordinate and the z coordinate. So, therefore, and that is why I call these classes are the primitive class, because member of this class basically either real number or integer. It is, again we really do not use any such sophisticated structured member in the primitive classes. Okay. So, these are the member for the points definitely. Now, again the vector, definitely it is again a real number, which is the x component of a vector, then y component of the vector and the z component of the vector. So, this is the member of the class vector. Now, this is more complicated class, I would say, compared to the points and the vector, but yet it is a simple structure. And inside the panel, that what are the member of the panel, that means what are the information you are going to store in this panel. First, you need a list of points. List of points is nothing but the four corner of the panels, right. This either is a quadrilateral panel or it is a triangular panel. If it is a quadrilateral panel, then it requires the 4 points. If it is a triangular panel, it requires 3 points. So, the collection of points or the list of points, you can say, like I do not use the word list, though I used in the code is a list of points. However, those who is not very much familiar with C++ or C#, they might not know what is the list function. Okay. However, for them they do understand what is the array. So, it is a array of points. Then I stored one information about the centroid, right. Definitely, because you place your the phi at the centroid. So, location of the phi is very important, right. So, now here so in panel we have the points we discuss all in the set of points with the coordinate and also the centroid. Okay. So, it is not a real number, everyone understand it, right. So, it is a typo, so I just corrected right now. So, it is a point, and then you have the area of the panel. So, that should be a real number, that is fine here. So, we have stored that area also, because if you remember that in case of a that one point Gauss quadrature rule, you need to find out the functional value at the centroid. So, you need a location of centroid and multiply by the area of that particular panel. So, therefore, in this panel structure you must have the area, and finally, definitely you need a vector which is nothing but the normal vector. Why? Because remember that influence coefficient is nothing but r dot n divided by r cube. Now, in order to get the n, you need the panel normal. So, this is the member of the panels, and finally, the matrix. So, the member of the matrix is nothing but the array of elements, right. You have the Aij matrix. So, you need the elements, also the row and the column, definitely that is how you can write the matrix. And also here I am not discussing about because the time is limited, we are not discussing about the functions I stored in all these classes, because in vector, for example, inside the vector class I need some basic function to be written, which is used by the user for various occasions. For example, just give some example, that dot product of two vector, cross product of two vector, and then finding out the unit normal vector, finding out the just normal vector. So, all these things should be written in vector. Even the matrix, there you need to inverse of a matrix should be there, that multiplication to matrix should be there, addition of two matrix should be there, subtraction of two matrix should be there, right. So, and also the identity matrix, like how to get it identity matrix, write a identity matrix just like that. So, this type of functions should be written inside this classes also. Apart from this primitive class, what more is required is the business class. Now, suppose you need to read the geometry and you need to write the output. So, you need the input output helper for to do that, right. So, therefore, this class is not the basic primitive class. This class mostly, you have to deal the business things. For example, I am reading the geometry, I am writing the output. So, for that I have one class which is the input output helper. Similarly, something called the output helper also, let us say. Sometimes you can have this integrating the Green's function also, you need some classes, right. So, these are not the basic thing, it is particularly these are the required to write the code, I mean to solve this particular problem. Now, in output folder what actually I write is I just, you can call that is the core engine also sometimes, because all this business logic to set up this influence matrix is written in the output helper. Okay. Now, so I write the influence matrix inside this output helper, I write the right hand side B matrix inside the output helper. However, to get this information, that the Aij, for example, I need a r dot n divided by r cube. So, this integration is required, and for this integration purpose actually I am having the class which is which help the output helper in fact. Okay. So, the name of the class is not integrating Green's function, the name is something, some other names is there in original code. However, just to make you understandable, so I just mentioning this. Okay. So, now let us, with this understanding, let us try to see the code. Okay. Now, this is the code. So, just try to make it little bit bigger, just I think it is bit bigger, you can understand it. So, here I do not have anything, so I just leave this. So, I can make this way. Okay. Now, here if you look at this, the top part here, first let us see this part. You can see here all this, see here actually there are many more classes, because normally one point Gauss quadrature does not work much, we have to go for the higher Gauss quadrature rule. So, other classes are also there, but this important class all everything is here. You can see here the matrix class. Now, if you click on the matrix class, you can see here that member variable of this matrix class. Now, if you look at it, it has row, column and the element, as I said, and then you can write this public method, that the typical function is written over here. Now, you can see that matrix multiplication with the first function, and then so this is one, and then you have the transpose of a matrix, and then you have the inverse of a matrix. So, everything is written in this the matrix, this class. So, let us see the vectors, the vector class. Now, if you look at this the vector class, and let us again this member variable again you can see it is this x component, y component and the z component, right, and all this and then if you look at this the public method, that is it is basically which the people from other from everywhere they can access it. It is that get unit normal vector, then it is get the normal vector, and then how to construct a vector. Suppose if you give the start point and end point, then it comes out to be the construction of the vector, and then the dot product, and then the cross product, and the modulus. Sometimes actually I write for particular for this purpose, give a vector and then the return back the modulus of this vector, because if you remember the panel area is half of modulus of this. Okay. Okay, fine. So, these are the primitive classes. Another primitive class is point. Now, again if you see these points, it is only has 3 member, which is the x 1, y 1 and the z, I mean x, y, z, 3 things, right. Okay. So, now let us see that how this program works. So, this is the main the code program.cs, where actually I find out the added mass. Now, you see here initially I am creating a list of points, which is the nothing but the points from the that is I used I mean the define the geometry of the body. Second one is it is the list of nodes. If you remember that point is associated with the node, right. Let us say point x 1, I mean 1 p 1, p 2, p 3, p 4. If this 4 point makes one panel, then in the node list it should be written as 1, 2, 3, 4. Let us say some p 6, p 8, p 10, p 12, these 4 points make make one element or a panel, then in node list it is written that 6, 7, 8, 11, something like this. Okay. And then I am using this input output helper, like, right. So, I just and I find it out the geometry. So, I send this point, I send the node list. Okay. So, this is the reference actually in this the get geometry in this function. So, this is first let us write the code structure, the systemic code structure. You can see that it is only this much, that whole thing is done only in this this is called the business logic. So, step by step. So, this get geometry means I am getting the geometry, and then it is something is a now I am creating. So, in this get geometry I am getting the list of the points and then the list of the nodes. So, it is my input. So, I am reading the input from the get geometry that function, and again you can see the next one, again input output helper get panel 3D properties. So, so in this panel 3D property, let us I get all the panel property. What is the panel property? So, if you remember in panel that all the member variable actually I am calculating here. So, what is the panel normal, what is the panel centroid, what is the coordinate of the 4 panels, and what is the these are the elements and the panel area. So, these are the thing actually I am getting in this function. Okay. Now, you see that this is how we write the business logic, then I write the influence matrix, right. So, once I know the panel and then I write the input the influence matrix, right, and this influence matrix it is written in the parameter, which is you can see it is the output param helper. That means, the as I said that this is the main core engine that helper, where I am writing the influence matrix, and also I am writing the right hand side the B mat or B matrix, that is the right hand side matrix, right, which is integration 1 upon r dot n into ds, that is I am writing over. And then you can see that I am now I am to do the matrix, influence matrix is there. So, I need to do A inverse B. So, therefore, I am calling this, I just invert that influence matrix. So, I am doing the A is the influence matrix. So, here I am finding out the A inverse, and then very simple, this I just find the identity, it is a check. Okay. So, it is the check is that I try to find out whether if I multiply the influence matrix with the inverse matrix. So, A inverse should be equal to I. So, this is the check. This check will tells me that yes, your inverse program is correct. So, once you do that, and then I am using the matrix multiplication A inverse into B, I am getting the phi. So, now when I getting the phi, and this is the value that I already calculated for the body, I try to find out the added mass, what is the mass of the body, because here I did not calculate programmatically what is the mass. So, it is the input, as I take this as the input, and then phi matrix I extract all the element, and if you remember that added mass definition is A I sorry phi I dot n j into d s, right. So, you need to find out this. Now, in this case my phi I also 3, because I am trying to calculate that A 3. So, I also 3 and then j also 3. So, therefore, my added mass is nothing but rho multiplied by phi 3 into n 3 into d s. So, this operation here I am doing, you can see here it is in the sum, I get the element, and then this I take the panel normal, the z component, which is the n 3, and then in this panel I just multiply by the panel area, right, and then element I 0 is nothing but the element of the phi. So, I doing so here I am doing phi I multiply by the panel normal multiply by the panel area. Now, if you keep adding everything, so you will get the total this thing. Okay. So, now with this let us now so here I am doing it for I take a barge type of structure, okay, and just let us run it. So, I just run this code. So, initially this is for some another problem. So, it is not connected to this here. So, I just press 2 because 2 is the radiation problem. See this why I ask this is for the several in later stage, when you calculate the Gauss quadrature rules and try to find out the over the element if the calculation 1 by r is correct or not. So, for that actually is for the check. So, it is, so we will discuss this problem number 1 later on. So, let us I solve the problem number 2 first. Now, if you do this, you can see that added mass, the non-dimensional added mass becomes 0.95. You can call this as the infinite added mass also. And in later stage, when you actually do the time domain panel method using impulse response function, that time this infinite added mass also required. Okay, but that time we found there is another way also finding out this infinite added mass, but this is one way you can find out the infinite added mass. Okay, fine. So, in fact, I have taken one more case, which is the wiggly hull. Now, this wiggly hull, I can show you that now here this getting the barge structure is very easy, and then but if you get the ship, as I mentioned over here to you, that if the panels are given, sorry, if the section lines are given, and then how we can make the panel, I discussed in the last class, right. You take this next point, this, then this point, and then that point, and then you can do that. So, I did that also. Here I had our own so this may be you can use for or you can share, in fact, if possible, I do not know, I have to see that. But now, if I run it, I mean if it is the here what is given here that you can create the section lines, and then from there you can create this code will helps you to create the mesh also. So, it's bit slow, so it will take some time. So, I just go this, so draw some basic geometry. So, this is something called the MVC model, that how we can view the thing. So, it is easier in MATLAB to visualize things, right. So, I just using this wiggly hull, you can see that. So, I just set the basic parameters. So, I just make it 100 and then breadth 0, fine. And let us take, because actually I just try to let us give it 6.25. I tell you the reason, and then I just make the water line 6. Okay. And just total section is 11. Okay, if I do that, so I can get the section lines, right. You can see here I can get the section lines. So, now I just export this section data somewhere. So, I just save it here. So, I just make it week 1. So, I just save it. So, once you save this data here, now you can see that it is one thing is given is the meshing. So, it just now you have this the section lines data you have. Now, you can just the mesh. So, you need to select that which section lines you need to mesh. So, I just give it this one, and then section lines and LBP is just cross checking. So, I said yes, this is the thing, okay. And then we need to mesh. So, I just create some new mesh here. So, I just save it. So, I just show you here, actually it is let us see the location. So, you have this new mesh. Now, if you look at this the mesh, you can see here the first is basically the all these points is given, and then with a space, and this is something called the connectivity. You can see that the first connectivity is 1, 2, 8, 7. Now, if you look at this the code here, one is minus 50, you can take the x and z, minus 50 0, 2 is minus 50 minus 1.25, right. And then the last 2 point is 8 and 7. So, if you look at this 8, it is minus 40 minus 1.25 and minus 40 0. So, you can see that I am making this the anti-clockwise notation, right. So, already I have done this, and this is already I use over here. So, instead of this I can go back to my the original code, which is input output helper, and I just change the file name here. Instead of dummy 2, I just it is the I think panel mesh. I this oh no, not here. It that is the commented line. Here I just use the panel mesh. So, I just check that if this is it. Oh, mesh underscore panel, sorry. So, now if you, and also I need to change the in the program the mass also, because that is I use as the input. Okay, it is there. Okay. So, this part I can ignore, simply just take any junk values. Now, you can see here, now this added mass is coming at 0.9. So, you see this in case of the ship, the barge, and here it is more or less 0.9 is coming at the heave added mass, right. So, if you remember that is when you solve the problem, that time also we use this, the heave added mass the 90% of the mass. Anyways, so this is how this is this is the way one should write the code. So, you make this code in small business logic, and inside this business logic inside this code you can further do the thing. So, the thing, let me show you only the influence matrix thing, which is which maybe you can see that is bit more complex. Remaining thing is very straightforward, right. Here see I did nothing. Here if you remember this one is the source point, which is the ith panel. So, I write the source point as the ith panel, and I take the centroid of this particular panel. So, this is how I take this, and if this I equal to j, I make it is minus 2 pi, right. And again if you see that if else I did not calculate here, see here you can see the code is very small. That is how you should write the each code. The code should, you can see this is that small code, and then here in the right hand side I am using that I call another function, which is the del g del n using 1 point Gauss quadrature. So, let us go there also. Now, if you go here, now you can see things are become very simple. Here I have only the source point, and then I have a panel. There I have the business logic. If I not equal to j, so I am sending you the jth panel, right, and I need to do that r I j del g del n by 1 upon r I j. So, I set the centroid of the ith panel and the whole jth panel, because to do the I need to, because I need the area of the jth panel, I need the normal of the jth panel. Now, you can see here I am defining a vector v, and then I just find it out the r, that r vector, which is x minus x xi, y minus eta, z minus zeta. So, that I do over here, and then I am using the dot product for the r dot n, right. So, I have already defined the r vector, which is v. So, I just v dot n. So, r dot n I am doing here dot product. So, that is why these vector things are important, and then I am using the that r cube. So, I am making x equal to the x minus xi, y minus eta, z minus zeta, and then I am making square root of x square plus y square plus z square, and that is my r, and then it is r cube. So, value equal to dot product divided by r cube, and then it should be multiplied by that panel area. That is how I calculate the interest matrix, right. Now, you see that this code also very simple, very small. So, that is what I am trying to tell you, that write the small part, break the code into as much small as possible, and then you integrate all these small pieces to write this the panel method code. So, I hope with this lecture, after having this 3 session on how to do the coding, you can really able to write this panel method code. Okay. Okay. So, yeah. So, next class onwards we are going to continue with the frequency domain panel method. Okay. Thank you very much.